Okay, hi everybody. Welcome to lecture 7. We're going to be talking about Ethereum and smart contracts today, and it's just me and Jake today. So some announcements before we get started. We have discussion 2 up. The topic is consensus protocols, and this will be due next Monday by 11:59 p.m. We've already seen some of your responses, and they all look amazing, so keep it up. We also have quiz 7 being released today. That's also going to be due next Monday at 11:59 p.m. And then just a quick note on attendance makeup forms. So we've received a few emails, and a few of you have talked to us about it, where your attendance grade is not being updated, but it will be at the end of the semester. So if you've been consistently filling it out when you've been missing lectures, then don't worry about your grade. So this is a very short table of contents for today. We have smart contracts, then we're going to be talking about Ethereum, then the Ethereum virtual machine, or the EVM for short, and then use cases of Ethereum. So first, let's talk about smart contracts. So can somebody tell me what a contract is? Just like a simple contract, what it does. Okay, no worries. We'll get into that in a few slides. But also another question, so hopefully you can talk about this with your neighbors. What makes Bitcoin so special? Why have we been talking about Bitcoin for 6 lectures straight? What's different about it than what we had before in the economics world or the technological world? So turn to your neighbor, introduce yourselves, talk about your favorite sport, and then discuss what makes Bitcoin so special. We'll give you like 1 minute to do that.
We're in game 7 right now, down 3-1. We just came back from down. We came down 3-1. We're in game 7.
What are you talking about? I don't understand it.
We're down 28 degrees. Patriots versus Falcons. I'm Tom Brady.
Okay, you should use this joke when I don't understand this shit.
The person next to me just got a 10 in all of dancing. Got a 9-9 in all of dancing. We need a 10 to win it. I have a sprained ankle. Okay. Show up, that's our sprained ankle.
Okay. Yeah, I like that. I love that you know it's the 10 to 9. Yo, sis, yeah.
Number. I know how a number is working.
No. How do you know how the system works? You watch like I thought you would.
Dude, I hope you never would.
You well, I'm sure you if I show you one, you'll like start watching it. Okay. 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 Does somebody want to answer this question? What makes Bitcoin so special? Please. Yes.
Decentralized.
Sorry?
Decentralized.
Decentralized. Yes, exactly. That's exactly one of them. One of the reasons why Bitcoin is so special. Is there another one that you guys know? Yes. Yes, exactly. It's a different way to store value and exchange value. Yeah, those are both great answers. So these are kind of the 3 that we break down what that makes Bitcoin so special. We have cryptographic identities. So everybody has pseudonymous identities on Bitcoin. And then it was kind of the first use of blockchain, and it was what first popularized the use of blockchain. So that's also why Bitcoin is so special. And then Bitcoin uses trustless consensus. So like you said, decentralized. So you don't have to trust one another in the network. You just have to trust that the system is working properly and the way that it's intended to. Yeah, so how can the benefits of Bitcoin be applied to other projects? For example, Ethereum. So it's pseudonymous. So cryptographic identities allow for accountability. And then democratic decisions are made through the consensus protocol, which doesn't require trust. And notice that we don't say proof of work specifically here. There's a lot of consensus protocols that also allow for not requiring trust, like proof of stake, and all of the other consensus protocols you all have been researching and posting on discussion too. Bitcoin also allowed for an immutable ledger of truth, so that's the blockchain itself, and that can also be applied to other projects. For example, in Ethereum, immutable just means once you add something to the blockchain, then it can't be taken away. Uncensorable and distributed go hand in hand, so it can't be controlled by one central party, and there's no central point of failure. So now we're going to define contract. So a contract is a written or spoken agreement that's intended to be enforceable by the law. So what does that make a smart contract? A smart contract is code that facilitates, verifies, or enforces the negotiation or execution of a digital contract, and a trusted entity must run this node. So we'll break that down in the slides to come, but for now, are there any questions? Okay. Now Jake's going to be talking about Ethereum.
All right. So now, sorry. So now I'm going to talk about Ethereum. And yeah. So what exactly is Ethereum? Ethereum is essentially a platform that's designed to run smart contracts, which Tiffany just talked about. And it was created by Vitalik. And originally, actually, the community had not liked Vitalik's idea for Ethereum, and they'd actually like not supported it. But then he obviously made Ethereum and obviously grew to a lot of users. So it shows you never give up on your dreams. You could start Ethereum one day. But yeah, it's a distributed computer to execute code, account-based blockchain, a transaction is equal to state function. And then yeah, the native token is called Ether. And so that's like the equivalent of like Bitcoin, where you can trade like Ether for USD or Ether for Bitcoin, that type of thing. But yeah, it's the basis value of the Ethereum ecosystem. So just kind of like going on to like what is Ethereum, just some quick like rundown of like how much Ethereum is and like the block creation time. So it's a lot faster than Bitcoin, which sits at 10 minutes. Blocks created in Ethereum are 13 seconds. And currently it stands at for 1475 USD for one Ethereum. And that's like the current rate. And then that was like what it used to be. Cool. Now kind of like talking about more like who would win Ethereum versus Bitcoin. We've learned about Bitcoin, so now we wanted to like do a direct comparison between the two. And looking at Bitcoin versus Ethereum, the main differences between the two is that the biggest thing is Ethereum is designed to run smart contracts, which allows to build applications and create complex and like feature-rich applications. So the other main idea is that Ethereum is an account-based system versus a UTXO system. And then, yeah, sorry, going back to like the smart contract idea is that Bitcoin is primarily designed as like a currency. You know, it's designed as like a peer-to-peer network where I can trade Bitcoin for like whatever I want to buy. Whereas like Ethereum, you have more of a smart contract. So this is more for developers who want to build out applications and want to do certain stuff on the Ethereum network. Are there any questions about that? Cool. So yeah, when looking at like Ethereum accounts, I kind of mentioned in the previous slide that Ethereum is like account-based. So what does this mean? Basically, you see in Bitcoin, we have the UTXO model that we covered in an earlier lecture. But in Ethereum, you can kind of like imagine this looks a lot more like a centralized bank, right? We have an account address, which can be like your public key. We have your balance of 10 ETH, and then we have like some code, which is like when I like do something, like when I send money to somewhere, take money out of my balance and put it over there. So it looks a lot more like a centralized system and like something that we're a lot more used to. So in Ethereum, there's two types of accounts. The first being externally, which is usually like someone like me or like someone like you or like a corporation. And this is like what we would use. So it has a public and a private key and basically allows us to like send Ethereum there and back. And then you have this idea of contract accounts. And contract accounts uses what we talked about earlier, uses like smart contracts. And basically it's owned by the contract. So when I do something or like imagine, you know, like an if statement, you know, when something happens, I'm going to execute some sort of function call or do some sort of message. So maybe it's like, I have some function that sends Ethereum somewhere, and then that'll all be handled by contract accounts. Any questions regarding that? Okay. So yeah, moving back forward, more on like smart contracts. Essentially, they're autonomous agents that react when they're poked. And this poking can be like some sort of transaction, some sort of call. It depends on how the developer designs it. And you can almost imagine that as like an if statement, like if I do something, then execute this smart contract. And through this, the smart contract control the internal ether balance and the contract state. And yeah. Cool. So yeah, just kind of like going back over, basically some main points of Ethereum smart contracts is to store and maintain data, manage contract or relationship between untrusting users, provide functions to other contracts, and complex authentication. Cool. Okay, so more on like how, so we talked about in the previous lectures how Bitcoin works off proof of work, which essentially you have like some CPU or some mining power, and you're trying to solve this complex puzzle. Ethereum recently switched to proof of work, proof of stake, or switched from proof of work on September 15th to 2022 to proof of stake. And like not like that stake, but like stakers, like STAKE. And instead of like having miners, you have this idea of validators, which essentially you want to lock up your stake. You have like some sort of Ethereum and you want to lock that up and you become a validator. And the reason that this is good is because it's a lower barrier to entry and better for energy consumption. Whereas like with proof of work, there's a high energy consumption because you're running these CPUs. It all takes energy to run those to solve this like hash puzzle. And then from there, once you deposit currency to become validator, which is 32 Ethereum, in the case of Ethereum, a validator is randomly selected to be like, oh, do I think this contract's valid or invalid? And the reason this works is that after a K number of validators, we're say, okay, this transaction is valid, and then we can like move on with the block. It's not just like one validator is picked and then they say, is this valid? Yes or no? And then move on with the block. It's like we select K number of validators. We don't exactly know what exactly this number is, but it's designed in a way so that we know this is like a pretty accurate representation of what the whole network thinks. Are there any questions about this? Okay, so pop quiz question, I guess. What type of transaction model does Ethereum use? And then you can take turn to your neighbor. Before you turn to your neighbor, maybe tell them if you like Bitcoin or Ethereum more. Okay, yeah. Discuss with your neighbor, I guess, if you want to. Oh yeah, after you turn your neighbor.
What do you like?
What?
What do you like?
You can do more like smart contracts, like just like fidelity is kind of interesting. Oh, there's also multiple answers. It's not just one answer.
Just like doing this stuff.
Did you like my slide? Mistake.
I like that I need to spell it out for them. It's not that big mistake.
One side.
STAK.
One side.
Did you speak on this?
Yeah. All right. Does anybody have an answer or think they have an answer? Yeah. Yes. There's also two more. Close. It's actually A, D, E, A, D, and E. Do you want to explain how you got A and E? It's fine, you don't have to. So yeah, okay, so going on with A, basically it's an account-based system. So the difference between A is that it's either an account-based system or UTXO in the case of Bitcoin. And as I explained earlier, Ethereum looks more of like a centralized account system where you have your Ethereum balance, and instead of using UTXO, which takes up a lot more space, it kind of just keeps on track how much Ethereum you have. So if you have like 10 Ethereum, it'll keep that stored. And then like when you want to make a transaction, it'll basically, you know, take that amount that you do the transaction from your balance and then send it somewhere else. Complex and feature rich. So like kind of what I mentioned earlier, this is, I guess, a little bit more difficult, but Ethereum is a lot more than just a currency. It's not just a cryptocurrency, like primarily how Bitcoin is used. You know, Ethereum, you can build a lot of applications, and the majority of like big blockchain applications are built on the Ethereum network using EVMs, which we'll talk about later. So yeah, it's very complex and feature rich. And I don't think they mentioned it, but Solidity is like the native code to Ethereum. So, and then it's a smart contract blockchain platform. Are there any questions about how we got that one? Here's kind of like what a smart contract would look like. This is Solidity. Yeah. Are there any questions? Cool. Feel free to come see us after too.
All right, now we're going to talk about the EVM. Okay, so Jake mentioned a little bit earlier that you can use the Solidity language to run the EVM code. And so there's two different languages that are primarily used on Ethereum. The first one is Solidity, the second one is Viper, and you can use one of them or you can use both of them together to create EVM code. So EVM on the high level is that it's a mini computer on your own computer that runs smart contract code. It also computes the state of Ethereum after every single block you add to the chain on Ethereum. So the contract code that actually gets executed on every node is the EVM code. So if you have EVM code on your computer, you can run it. And then if somebody else does, they can run it as well. So everybody has the same state of Ethereum on each of their computers. And EVM code is low-level stack-based bytecode language. It's kind of like the JVM code. And every Ethereum node runs EVM, so that's very important to note. So here's a question. What if our contract has an infinite loop? So what if it never terminates? Then what happens? So then every single computer has to run this infinite loop, and then like it'll never stop. So again, yeah, every node on the network will get stuck executing the loop forever. And by the halting problem, it would be impossible to determine ahead of time whether the contract will ever terminate. So this would lead to a denial of service attack. So this just means, oh, if one smart contract is running forever, then the next smart contract can't even be executed. So then it denies service to all the other contracts that want to be executed after that. So is there a solution to this? Does anybody want to take a guess? If there's a solution, yes or no? Okay, I see some thumbs up. So yes, there is a solution. So on Ethereum, the solution is that every contract requires gas, which fuels contract execution. So every single EVM operation code requires some gas in order for you to execute it. So how this works is that there's a start gas and a gas price. The start gas is set by the person who's trying to get the smart contract to run. And this is the max quantity of gas that it's willing to consume. And then the gas price is the fee in Ether it is willing to pay per unit of gas. So that was a lot, but essentially you just multiply start gas and gas price, and that's your gas. And that's being subtracted from the sender's account. So that's the person who's wanting the contract to be executed. So you set this gas price and start gas at the very beginning of your transaction. And then you're saying, this is the amount that I'm willing to pay. And then if the contract successfully executes, then the remaining gas that you didn't use is going to be refunded back to the sender. So the gas is going to be used over time. So if your smart contract is being run forever, it'll eventually stop. So what happens when you run out of gas? So when you run out of gas, then the execution, it just stops and we go on to the next thing that somebody else wants to execute. And then your start gas times your gas price will not be refunded at all. So you've used all of it. And so now you don't have anything to be refunded back to you. But if, for example, your gas didn't run out before you already executed your smart contract, then that would be the second bullet point where the remaining gas is refunded back to you. And so purchasing gas is, you can think of it as purchasing distributed trustless computational power. So what this means is that you're purchasing, like you're paying for people to run your smart contract on their EVM. And an attacker who's looking to launch a denial of service attack will need to supply enough ether to fund the entire attack. So they would have to, if, for example, it's an infinite loop, then they'll have to give an infinite amount of gas for that to continue running, but that's not possible. So this is why this is a solution to prevent denial of service attacks. So this is just code that shows you how you can update the EVM with whatever smart contract code you want. So block state prime is on this side. Essentially you feed into it how you want the block state to look like after the code is run, and then you give them the gas which is again the start gas times the gas price, and then it goes from one state to the state that you want it to if your gas does not run out before the smart contract code executes completely. Okay, another pop quiz question. Turn to your neighbor. This time, what should they talk about? Okay, talk about if your power's out right now because of the rain. And then talk about what do start gas and gas price refer to. Yes. Okay. Does anybody have an answer to this question? This time it's only one answer, so 1 out of 3 chances of you getting them correct. Raise your hand if you think it's A. Raise your hand if you think it's B. Raise your hand if you think it's C. Okay, so the answer is B. A lot of you got that. So the start gas is the maximum amount of gas that the owner is willing to pay, and then the gas price is the price of gas in weight per unit. And we got a good question from this side of the room, but basically the question was, why would somebody want to put a higher gas price over like a lower gas price if you execute the contract code anyways? So the answer is, it's very similar to how transaction fees work on Bitcoin. So if somebody sets a higher transaction fee on Bitcoin, people would want to put their transaction on the chain before somebody with a lower transaction fee. So it's the same thing with gas price, where if you have a higher gas price, then somebody might want to put want to run your smart contract over somebody else's first. Yeah, so B's the answer. Okay, so just some conclusions about Ethereum before we get into the use cases. So Ethereum is not about optimizing efficiency of computation. It's quite slow, it's quite tedious. You have to run the same thing on every single node, and its parallel processing is redundantly parallel. So this is just a better way to reach consensus on the system state without needing to trust third parties. So of course, Ethereum isn't, or the blockchain shouldn't be used for every single use case, but if you want, to reach consensus without a third party, then Ethereum would be the answer. So contract executions are redundantly replicated across the nodes. Like I said earlier, it's expensive, it's slow, and it's memory intensive. And this really does create an incentive not to use the blockchain for computation that can be done off the chain. So then when do you use blockchain and when would you use like a centralized database that we see on a daily basis? So if you want to use the blockchain, this would be mostly for a shared database with multiple writers. You would use it when parties can't trust one another. Sorry. Do I have to do this? Give me 1 second. Okay. So this is when parties can't trust one another and no trusted third party or authority is available. And you would also use the blockchain if you're interested in fault tolerance, which we talked about, I think in lecture 5 or 6, and data immutability or censorship resistance. That's also very good if you use the blockchain. But when would you use a centralized database? So a database does not need to be shared, or it's shared by parties who trust one another. That's when you would use a centralized database. You would also use a centralized database if you're trying to keep data confidential or you're handling complex and large amounts of data, because it's going to take a long time to be run on the blockchain if it's a very, very large subset of data. You need to be able to edit the data. So since blockchain is immutable, you wouldn't be able to update it. So that's why you would use a centralized database if you want to update data. And you would also use a centralized database if you're interested in cost effectiveness, speed, or efficiency, which is a lot faster than the blockchain. Are there any questions about EVM or Ethereum or gas price or anything like that before we get into use cases? Okay, so now let's talk about use cases. These are just a few. Has anybody heard of ERC tokens? Okay, so ERC tokens are essentially a tool for governance. So if I am part of a protocol and I want to govern what's happening on that protocol, I would get some tokens, ERC tokens. You can buy ERC tokens using ETH. And then you would be able to use that in order to decide what happens on that specific protocol. And so earlier we talked a little bit about decentralized applications. So those are just applications that are run on Ethereum, and then they would use tokens in order to govern their protocol. And one possibility is to use the ERC token or any token that they create on their own. And so here on this slide, we just see a token system implementation. This code is not necessary to know, but if you're a technical person, if you want to know a little bit more about the technical aspects of Ethereum, then you can take a look at this. Essentially, this is recreating Bitcoin in 4 lines of code. So this slide is just telling us that Ethereum is able to create Bitcoin like in the simplest aspect in 4 lines of code. Essentially, if Alice is a sender of Bitcoin and Bob is a receiver of Bitcoin, then we have to ensure that Alice has enough money and that she can initiate the transaction. So what this function is doing is if you want to send something, you have to put a 2 person. So that would be Bob, the value, which is X amount of dollar or X amount of Bitcoin. And then if you in your current wallet have greater than or equal to the amount that you're trying to send, then you would be able to subtract that value from your current wallet, and then that person that you're sending it to, so Bob in this case, would add that amount of value to his wallet. Yeah, this is definitely a very simplified version of what it would look like, but essentially it's just saying a smart contract would be able to execute the transactions on Bitcoin. So another use case is the public registry on Ethereum. So essentially there's the domain name system, and this is what maps domain name to IP address. So, or IP address is also your Ethereum address wallet, Ethereum wallet address. So for example, Jillian Chu can map to that number right there. And this just makes it easier for you if you want to like send something to somebody with an ETH wallet, but you don't want to type all of their Ethereum wallet addresses out. So this is very easy to implement in Ethereum. You would register, so you would use another function, for example, this one right here, you would input the name and then what value you want to map it to. And then if that name currently isn't in the storage, then you would be able to, set that name to that value. And so you can think of it like a username kind of. Like on Instagram, for example, you wouldn't have 2 people with the same username. So this leads me to proof of existence. So what proof of existence is you're proving that you own something without actually having to show people what that thing is. So for example, this is like a real world example where in the US Postal Service, if I had an idea and I wrote it down on a piece of paper and then I put it in an envelope and I timestamped it to show that I had this idea that I put on a piece of paper, put it into the envelope, and then I shipped it out to someone or to myself from the US Postal Service, then in court, if somebody's like, oh, I had the idea before you, I'm like, no, look at this envelope, look at the timestamp, look at what's inside, I had this idea before. So that's kind of a real world example. I don't know if that actually happens, but essentially proof of existence is also possible on Ethereum, and all of that happens virtually. So yeah, timestamps verify ownership later. Okay, another use case is land titles. So has anybody heard of the MLS in real estate? Yeah, so the MLS is basically just like the registry of every single house and like who owns it and when they started owning it. But there's like a few problems with that, where like some people don't trust the government, some people don't trust that, you know, like their house is going to be on the MLS properly, and then they don't want people to know, they want to be more private, they want to be more secure. Some sellers, they might want to do that on the blockchain because they don't want to go through an agent, which this is a whole thing about the real estate industry, but we're not going to get into it. But a buyer might want to not have less competitors, so they wouldn't want to go to open houses either. So just a few things to think about. And if you want to avoid all of that, then you can buy a house or buy a piece of land and put that on the blockchain and just like completely not go through any governmental agencies or governmental entities in order to do that. But there's obviously problems with this. So there's flawed paperwork, forged signatures, unclear documents. It's also lacking central government authority. And, you know, corrupt officials could accept bribes, they could tamper with records, and then the government can't support land record authority if it's not, you know, physically in their documentation. And citizens are mistrustful of multiple non-governmental organizations. So there's obviously pros and cons to both sides, but this is just another use case that could potentially work on Ethereum and other smart contracts. So there's quite a few countries who are investigating this, Georgia, Ukraine, and Sweden included. A caveat to this is that the blockchain is only as good as the information fed into it. So this goes back to the idea of garbage in, garbage out. So if you feed Ethereum very good information, if it has robust smart contracts, then the output is going to be good. But if you feed it bad stuff, and if there's only one person feeding it information, then it's not going to work the way that you intended it to. So that goes back to land titles, because if only some houses are on the blockchain and then some of them are on normal documentation by governmental agencies, then how do you kind of weigh the two and look at both, or which one is going to be more popular than the other in the future? So these are just some things to think about. Okay, now we're going to talk a little bit about DeFi, but please hold your questions about DeFi because we're going to have a whole lecture on that next week, and we have two very wonderful guest lecturers coming in for DeFi. So I'll just give a very brief overview of how that is applied here in this case, but just save your DeFi questions for next week. Okay, so the problem is that most of the traditional finance is closed to regular users. What this means is that most, like stocks, derivatives, or other assets that are built on top of cryptocurrencies are in centralized platforms. So the idea is to move that to decentralized platforms. And I know we've also talked a little bit about exchanges and DeFi in previous lectures, so this would be a little bit of a recap. But essentially, financial institutions can manipulate markets, retail users could be priced out, and people are distrustful of big banks. So what's the solution? The solution would be decentralized finance on Ethereum. So on Ethereum, you can build dApps, which are decentralized applications, and you do so using smart contracts to handle the logic. And so these are some examples of DeFi protocols. This is Uniswap, which is a decentralized exchange. And then there's Aave, there's lending and borrowing protocols, there's Open, and then there's so many more out there. I can't even list all of them, but yeah, so with DeFi, you can use game theory and economics to find ways to cut on trust. So this is referring to lecture 5 and thinking about how game theory plays into how DeFi works, or even how TradFi works, or finance in general. So the idea is to rely on the Ethereum blockchain to verify the transactions, which goes back to using smart contracts to do all of that. So some drawbacks to this is that it's capital inefficient. So banks have been around for a long time. They know what they're doing. They know how to be efficient. They know how to get people to trust them. But DeFi is a relatively new space. So there are a lot of risks that are unforeseeable. So risk from smart contracts and attacks, funds can get drained, and adversarial miner behavior could occur on these DeFi applications. And the idea is that because it's such a new space, if an attack happens, that could possibly be the first time that that type of attack has happened. And so these protocols would only be able to combat that after it has happened, because now they know, oh, this is a type of attack that could happen. I'm going to try to combat it. So yeah, there's definitely other things that you can think about with regards to risks of DeFi, but it's just a very exciting space because it's so new. Are there any questions about use cases? Yes.
Can you explain again why it's capital inefficient?
Yeah, definitely. So it would be inefficient because, like I said, for smart contracts, it takes a while to, to get them to run on every single node who's running the EVM. So it would be inefficient because of the time that it takes to do that. But with banks, you deposit something, then it gets in your account automatically. You don't have to wait for anything. So that's why. Any other questions? Okay. So our attendance code today is EVM, and all 3 letters are capitalized. So yeah, thank you for coming on a rainy day.